Good afternoon there to all you wonderful physics students all across the country. I was just thinking there, what a wonderful way to spend a Saturday afternoon discussing the delights of leaving cert physics. Okay, now my name is Pat Doyle, and I think what you're looking at there right now, what you see a kind of a screen here, that's me here, good old Pat Doyle. That's my right hand, by the way. And then, of course, if you'll also notice there's a small little kind of say picture of me there as well. That's me kind of say waving at you, okay, there as well. Although I'll be mainly, I suppose, interested in what I have to write down here really than actually looking at my good self, okay? Now, a couple of small little matters I was just going to explain there to you. First of all, you're all very, very welcome here to this masterclass in physics at the Institute of Education. Um, I wanted to kind of look at three things here, Shay, this afternoon. First of all, comment briefly on maybe say how best to say to prepare and to study for Leaving Cert exam itself. Secondly, just to talk a little bit about what to do on the day of the exam, things like timing and stuff like that. What questions are best to look at, and then thirdly, what I wanted to do was pick kind of a few little topics that are actually on the Leaving Cert. Just go through them with you to give you a kind of a flavor of the way I would teach the kind of stuff that I would do here when I'm teaching in the institute. And it would be the same kind of approach I would take whether I was teaching you, so say, online or physically on site in the institute classrooms itself. Okay. So I'll start off with that. So you're all very, very welcome. But what I'll just do here, first of all, is one small little thing, and is the following. You don't mind if I just write down a few bits and pieces as I go along. And then I'm talking here a little bit better way initially say about how you would say study physics. Now, one thing just to kind of keep in mind, I think, is you guys will be the 24th set of students to sit this exam. Your exam dates all the way back to the year 2002, and up to and including, shall we say, last June, we've had 23 leaving certs. Now, you're, say, leaving cert 24, and basically, as we understand, there's one more after you guys, 2026, and then that's it, say, new syllabus kicks in. The reason I draw your attention to that is if there's only, say, 2 years left, your year and 2026, you're not going to see anything wild and wonderful in the leaving cert. In fact, what you're going to get is, to put it very bluntly, is a huge level of repetition. Now, when I mention repetition, what kind of jumps at me certainly straight away would be what I would call the questions we meet in, say, section A. So that's just the first thing I was going to mention there to you. And another way in section A, you have what we call the mandatory experiments. And of course, you know the routine. There's actually 24 of those, should we say, in total, 24 experiments in total. And basically, on the day, what they will do is they'll pick 5 of those experiments and they'll actually make up 5 questions. Now, the one thing to remember is just this here. Whatever questions you get, they're going to be what I would call repeat questions. This was important because the reality is if you just do the actual mathematics, if they now when I say they ask 5 questions every year, that's been since COVID. Before COVID it was 4 questions, okay? But even still, at this stage, if you actually work at it mathematically, you're talking there to say almost in the region of about 100 questions, okay? There's 24 experiments. And the reality is that almost all the experiments have been asked multiple times, okay? So it's almost a case of no matter what 5 questions that appear on your examination paper this coming June, they will all be repeats. Now, when I say repeats, it's almost shocking how, say, similar the questions are from year to year. So basically, what you need to look at more than anything else, more than any textbook, any notes you might get from a teacher, would be what I would call very, very simply, to spell it out here, very, very simply, guys, what I would call here the past paper questions, okay? Now, what I do myself, say, in the institute is I actually give out a kind of a separate set of what I call questions and fully worded answers. That's basically part of what I do on the various courses I teach here. But even if you don't have access to something like that, what you can actually do, if you don't mind me saying so, is you can just go online. You can actually get the questions on the Department of Education's website, like examinations.ie, and you can actually get the marking schemes. And while the marking schemes are not like fully worded solutions, they're still not bad. You get a lot of information from the actual marking scheme. And what I would suggest, what I would do if I was in your shoes is, if you think of it, guys, if there's 24 experiments, why don't you give yourself the task of taking maybe, say two, well, let's write down EXPT as a short way of spelling experiments. What if you just take maybe say 2 per week, should say over the next 12 weeks. Now, if you decide to do something like that, that kind of brings you up to the latter end of May, which would be just perfect timing. Okay. And for example, okay, if I just throw, say, two questions at you, just say, for example, you were starting maybe say with mechanics, okay? And I said, okay, I'll do the G by free fall. I'll have a look at that one. And I might maybe have a look at the one for, say, Newton's second law. Now, what I would do is, okay, rather than going through my textbook, okay, or as I said, notes, I would go back to the past papers, find those actual past paper questions when they last featured, and have a look at what they basically asked to do. Now, you have access to the question on the department's website. You've also got access to what's called the marking scheme, which in plain English, I suppose, really is actually the actual answer. And very, very simply put, you'll see exactly what they ask you. So you'll be left to no doubt. Now, one little thing that puzzles people, you might have actually noticed, is when you look at all those past paper questions, they do not, I stress, they do not ask you to write out the entire procedure. I'm always fascinated. Many students will maybe say, go to a textbook, learn off 10 lines of the procedure. And if you actually check, they actually don't ask you that, okay? What they do ask you would be, say, things like maybe, say, draw a diagram of the experimental arrangement. And in most cases, okay, like the way the questions, say for example, say in section A are worth 40 marks each, usually 12 of that 40, which when you work it out, guys, is 30% of the question goes to drawing the diagrams. Now, let me ask just one very simple question. How do you practice draw diagrams? How do you kind of get yourself to know them? Okay, I'm just going to a simple one at you here. Okay, I mentioned there, say the G by free fall. Now, when I would draw that one there, what I would actually show here, first of all, is a small little, what I call, say, piece of iron like this here. I show a piece of wire kind of wrapped around it in this kind of a manner here, say like so. And then there's the two ends of the wire like this. And then come along like so. And I'll bring it over here, maybe say to a little battery like this here. And install an unusual looking kind of a switch, which I'll just draw like this here for one moment. And then just bring it along, maybe so say like this here. Okay. Now, what I then come along and do is down here, I'm going to draw in what we're going to call maybe say a little trap door, okay? Little wire maybe going up to the positive end of the battery like that. Another lead coming along like so. And then in here, okay, what I would have is maybe say some kind of a timer. And then say bring the timer up here, maybe say like this. And basically the reason I have the switch is that arrow can touch either of those dots. So if I just call the dots maybe say A and B, you can touch A, you can touch B, but obviously you can't touch both. And if you touch A, then what happens is the electricity goes through the wire that's around the piece of iron, and you actually have yourself what we would call an electromagnet. And then if you touch B, that allows the ball to fall because you don't have a magnet anymore and allows the timer to start. But the point I'm trying to get across is, can you do what I just did there? Can you actually draw that? Now, I don't know what works for you, but a piece of advice I got from a teacher about 5 million years ago was what you do is you get a pen and you get paper and literally practice drawing it. So literally, if you said, I'm going to give myself an hour, maybe say next week to say work on maybe say two experiments, I would actually, if that was one of the ones I'd be doing, I would certainly draw that at least two or three times. Now, anyone looking at you, let's say you were maybe in a study hall, some might think, oh, your man over there, he's doodling or he's messing, but you're actually not. Because what I find is, I find if I draw something, it stays in my brain. If I just kind of say sit there looking at it, okay, I have it forgotten, like 2 hours later. Okay, to put it very simply, I would regard drawing it, practice drawing it, as a kind of an active thing rather than a passive thing of just kind of say sitting there. Now, I mentioned there about the experiments, they'll actually ask you in this case here to draw the diagram. Another thing to watch out for is they'll always quiz you on the data, like not the procedure, just basically what measurements do you take. And the bizarre thing is, if I take the example of this experiment here, I measure two things. Okay, let's get my red pen here. I basically measure the distance the ball fell. Okay, and then just for the record, that's from the bottom of the ball to the door. Okay, that distance. Okay, S. And I come along and I also measure, say, the time t that it took for the ball to fall from there down to what's called the trapdoor. Now, very, very simply, all you have to be able to comment on is the distance and the time, not the big long-winded procedure. And you'd obviously measure the distance with a meter stick, it measures the time, which are a little, so say, millisecond timer. So you have your diagram, you have your data, okay, like that there. And then very, very simply, okay, they'll actually expect you to do the calculation. Now, the one little hiccup, say, with this experiment is, there's a famous formula that actually goes with it. Okay, I'll just pop this page over here for one little second. And the way we actually calculate the acceleration due to gravity is we have a formula that actually says it's 2s divided by, say, t squared. Just give a little example like this here, okay? Now, annoyingly, that's not in the maths tables. So you say, okay, right, I've got to get that one clear in my head. I have to kind of say memorize that. Now, if they give you a question on G by free fall, you can put money on it. You know what I mean? You can like have a little wager that he's going to actually ask to draw a graph. And what I always say to students is, the golden rule with graphs that works really well for the leaving cert is whatever is above the line is the y-axis and whatever is below the line is the x-axis. I always think of it as y's over x's. And what helps me to remember that is, the famous old slope formula. Once again, the y2 minus y1 over x2 minus x1, like y's over x's. Or if you like a bit of maths, I always think of, the old dy dx, like basically the y is above and the x's are below. So basically your y-axis and your actual x-axis, okay? So 2s would go on the y and then t squared will actually go on the actual x. So you have your diagram, you have you're just what data you measure, how you measure it, your mathematical formula, okay, which usually leads into a graph, and then one final thing. Can you mention one or two things that you could do to improve the accuracy? And I don't mean like 10 ways of improving the accuracy, just one or two things you could actually come up with. And that's basically, okay, what it is. So if I was to summarize that, okay, I'd say, right, like here, I'd come along here and I'd say, make sure you have a diagram for each of your experiments, okay? Make sure you can comment on what data is measured and how you would actually say measure it. So say like this here. If there is a maths equation, which is going to be, make sure you actually know that, okay? If they actually ask you to say to be able to draw the graph, make sure you know what way to draw the graph. And then very, very simply, I'd come along here and I'd write down the word here, should say accuracy, okay? Have one or two ways of improving the accuracy of the experiment. And that's basically that. And one thing that people forget is, what if you plan this carefully? What if you say, okay, I'm going to do 2 experiments per week, okay, over the next 12 weeks. And what if on the day, you managed to do really well in section A. Now, I always encourage my students to go all out. The word I use is to ace it, to get as near to full marks as you can. And what if, say, on the day, just, and I'm serious about this, what if you got, say, the full 120 marks? Because you have to do 3 questions, okay? And if you don't mind me saying so, the word 40 marks each, so that's 120 marks. What if you got nearly all of 120 marks? Do you know when you move into section B, that gives you the ability, this sounds bizarre, to make a lot of mistakes and still score a H1. I kid you not. Because, and I'm not trying to be silly when I say this to you, but like you can afford to lose 40 marks in section B. That's a lot of mistake. That's a lot of mistakes, guys. And still, you will technically end up with a H1. Because like a H1, as we know, is 90%. And because the exam is marked out of, say, 400, okay, what you need to do is get 360, say, out of 400, okay, and you're in business. And as I always say to students, whether you get 360, 361, or 399, it's still a H1. Like there's no H1 super pluses. Like, that doesn't exist. Like, and that's why I say so. I always feel somebody who goes all out really aims to absolutely ace section A. They give themselves what I call the ability and the freedom to make a lot of little slips and errors along the way in section B and still score very high marks. Okay, so that's very much what I would say there to you with regards to say to that there. So just thought I'd mention that to you first of all. So do please put a lot of time and effort into what I would call, for example, should say here, say the section A. And again, I repeat again, be guided by the good old, say, past paper questions. That's really, really, really what I'd actually be working on. Okay. Now, with that being the case, just one of the small little matter, just while we're here, okay? You might say, Pat, the way there's 24 experiments, would I be safe to ignore the 5 that came up last year and then maybe say learn the other 19? Guys, you're gambling there. You're gambling a little bit because we have had scenarios where where he has kind of say repeated an experiment 2 years in a row. We actually have had several examples of that there. However, okay, let's just say like realistically, like you're really, really busy and you just don't have enough hours in the day, well then what you could say is, what I'll do, of the 24, what I'll do is I'll focus on the 19 that did not come up, for example, should say in 2024. Okay, that'd be my main 19. And if at all possible, I try and dip into the other 5. Okay, now put it this way, is there is there a chance that all 5 questions next June will be a repeat of last June? No, that's not going to happen. That's not going to happen. Okay, he might repeat one of them on a really bad day too. Okay, so the funny thing is, like, your main priority would be, I said, the 19 that didn't come up, and then I would have a little peep, maybe say at some of the ones that say that actually were there as well. Like in an ideal world, you do 24, but we don't live in an ideal world. We live in a real world. Okay, and I'm very much a realist myself, so you have to kind of cut your cloth to suit your measure. Now, one small little thing, just by way of again, okay, and it's just this here. Apart from just what I call a section A, there's one other thing that sometimes puzzles people. I'll tell you very simply what it actually is. It's the idea here, guys, of what we call, say, definitions. Now, whatever the hell you do, don't go learning all the definitions in your textbook because I say a good half of them never feature. So let me just take a little example, okay? Say I said to you, okay, let's take maybe say the section say here dealing with light. Now, if you want to know what definitions he's going to ask you, you basically sit down and here we go again, okay? Can I use abbreviations of PPQ as in past paper question? What you literally do is go back over the past papers, literally start with last June, go back maybe say 10, maybe even 15 years, and have a look at what definitions he's asked. So say even in the last 10 years, and there you have this year's definitions. I kid you not, okay? So there's loads of stuff that you will see will be listed as say in textbooks as definitions, and they simply will never feature. Okay, and again, you see that's why I'm a huge fan, say, of actually say using these here. Now, just for what it's worth, I should say, like say, in a couple of years from now, when we're doing a new syllabus, I won't have that luxury. The students won't have this luxury because there won't be any past paper questions. But that the reality for you guys is we have them. There's loads of them, okay, out there, and use them. And the same way, like if you said to me, Pat, what's most likely going to come up as a definition, say in electricity? Go back over the electricity past papers and dig out the definitions, and you're going to say, oh my God, it's the same 4 or 5 all the same time. Okay, so that's why I say you do not go and learn all the definitions in your textbook. For God's sake, that'll just torture yourself. You literally be guided by what is asked in the past. And I keep stressing because there's only 2 years to run on this. You're not going to find anything wild or wonderful. Absolutely not at all, at all. Okay, now with it being the case, there's one other small little comment. I just want to kind of guard against this, and it's the following. Since COVID, he has increased the number of questions on the exam. So, for example, okay, say in section A, you guys are actually asked to do 3 questions, okay, say from 5, and then maybe you should say in section B, like this here, you do say 5 questions, okay, out of a total say of 9. So it's a lot of choice. But some people have said to me, do you know what I'm going to do? Because I got 5 out of 9, I could actually leave out 4 topics. That'd be absolutely dangerous. That would not be a good idea. When you're planning your study, in an ideal world, again, I'd say to somebody, leave nothing out, cover every single topic, okay? Because I'll tell you very simply why I would say that. The examiner is well known for mixing topics together. It was only there actually during the week. I was showing my day school a question. We were doing something, by the way, with regards to, say, sound. And there was a gorgeous little question, fabulous little question, but half it was sound and half it was light. So what if you were somebody who did sound and did not do light? You would have got badly caught out, okay? And he has a tendency to say to mix topics together, and he could mix almost anything with anything, okay? Now, that's what I say, the ideal world. But like, as I said already, we don't live in an ideal world. We live in a kind of a real one. And my point then very simply would be that if you had to kind of cut corners at the absolute max, okay, I would say, then maybe say leave out maybe say at most 2 topics, absolute max. You see, when a student comes to me and says, Pat, I just don't have enough hours in the day. I can't cover like all the topics in the leaving cert. What should I do? The first thing I ask that student is, what grade are you looking for? I really mean that, okay? And if someone said to me, Pat, I'm looking for a H1, the real advice I give to a H1 student is, you know what, try and leave nothing out, and at most 1 topic. Now, if someone said to me, Pat, I'm looking for a H3, if I got a H3, I would be delighted with myself. Now, that's different. That's a different advice altogether. A student who's chasing H3 can easily afford to leave out 2 topics. Absolutely, yes, no problem whatsoever, okay? You can easily stretch nearly to 3. You see, a lot of it depends on, okay, shall we say, what grade you see yourself at. Now, you know the way I mentioned the section A, there you see, go back to what I said. If you have everything done, organized in section A, and if you can do incredibly well, that gives you a huge boost, okay, and gives you, as I say, the ability to make a lot of mistakes, okay, get things wrong in B, and still score a very high grade. So really, in very brief summary, what I was trying to get across to you was I lift up this page here. Once again, I was just talking to you briefly, okay, about really focusing on the old section A. I mentioned there to you that when you're doing those experimental things, there's the 5 items you're looking for: your diagram, your data, okay, make sure you know the maths formula, okay. If there is a graph, make sure you're clear on what the graph would be, and then one or to be honest, maybe say 2 ways of improving the accuracy is usually what you actually need in that case there, okay. And the tip I got from a teacher many years ago, and it stood me so well, not just in Leaving Cert, all through college, is one of those: a pen and loads of that stuff, pen and paper, okay. And you handle of a lot, you'd be tired writing. But the thing is, I felt I could study for like a long time. I could do a couple of hours study if I was writing. If I stopped writing and just start to read, I fall asleep after half an hour, okay. And that's why I say it's a difference between what I call active and passive study. I'm an absolute total believer in say writing stuff out, okay. Now, With that being the case, okay, what I'm just going to do here very briefly is, okay, I'm just going to deliberately kind of come along here for 1 second, okay, just pop that around, okay, let's kind of get rid of that there for one little second. And what I wanted to talk to you about just very, very simply was on the day of the exam itself, just a couple of small little things just to kind of keep in mind about the exam itself, okay? Now, one of them is just this. The first thing people say to me is, Pat, what's the deal with timing in the exam? Now, what I'm going to say to you might surprise you ever so slightly. I have a golden rule, very, very simply of give yourself 20 minutes, okay, for each question. Okay. Now, the first thing people say, well, hold on, Pat, hold on, Pat. You say 20 minutes for each question. Surely you make a difference between A and B. No, 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 I don't. I actually mean for each question. And I know there's 40 marks going in, say, the section A questions, and there's 56 in B. So you might say, pathologically, surely you'd give more time to section B. And I say again, no, no. Because you see, what I always recommend to people is just this. I always say, okay, when you enter the exam, so like on the day of the exam, it's going to be, say, starting in the morning at 9:30. Okay. Now, what I would suggest there to you is you have to answer three section A's. That's three 20 minutes. Okay. So basically, it's going to be, should we say, in this case here, the 20 minutes, okay, times three. So basically, you're talking here a grand total, say, of 1 hour. And what I've often said to people is on the day, when you open the examination, get stuck in straight away to section A. Now, people say, oh, for God's sake, Pat, I'm going to have to read a whole exam. Well, no, you don't have to. Like you'll read the exam in a moment's time. But the thing is, I would say literally hit the ground running. Take out the pen and the paper. Start literally writing, guys. Okay, at 9:30, okay, in the morning. Look at you look at your five experiments, and what you'll find is usually there's one. I don't like that, and then you're him and which three the other four will I do? I pick your three and then get stuck into them and give yourself 20 minutes each. Now, the gas thing, and the reason I say this is on land, I'm not just kind of say this from nowhere. Every year, that just sounds funny, guys. Every year, I actually sit the exam. What I mean by that is about 3 or 4 days when the leaving cert is all over, I actually take out, I sit down, okay, you usually with a fine big mug of coffee, by the way, and I actually start writing out the answers to the exam, longhanded with a pen and paper, okay, and I time myself, okay, because I do this for a reason. I do this so that I can advise my students how best to deal with things going forward. And what I do is I answer all the questions on the exam. Now, I usually actually have to stop for lunch, okay? But what I find is I find it takes me as long to do a section A as it does a section B question. You'd imagine because there's kind of say only 40 marks, but see what you mustn't remember forget is in section A, things like graph drawn slows you down. That slows you down quite a bit, okay? And so on. So what I'm saying is I'm giving myself 1 hour to take care of section A. And I think most people would agree even if you try a sample question yourself, that's about just about the right time for that. Okay. Now the trouble very, very simply is just this. Okay, just give me one small little second, okay, and it's just this. What happens then is, okay, say you're at 10:30. Now, when it comes to say 10:30, now what I do is I say, right, now let's tackle section B. And the first thing you see I've got to do here is I've got to read, I'm going to write down here, say all the questions. Now, you see, you know the way I was saying 20 minutes for each question. If you think of it, guys, okay, in total, in grand total, okay, you're going to be doing 8 questions. Now, 8 times 20 is 160 minutes. Because it's a 3 hour exam, you have 180 minutes. So you have left 20 minutes to spare there, okay? So basically, you see, basically what it actually means is you have a spare 20 minutes, but part of that spare 20 minutes is going to go for reading all the questions. When I say read them all the questions, and then really importantly, okay, choose what you think are your best questions. Okay. Now, I'll be honest with you, unless you're incredibly fast at reading, that's going to take you, I believe, nearly to close to say 10 minutes. It might even take a little bit more because you see, choosing the questions is really, really important on the day. Because the last thing you want to do is find yourself spending 10 minutes in a question and then realizing, oops, or whatever word you might say yourself, I shouldn't have actually done this question. That was a bit of a bad mistake. So you're desperately trying to avoid, so say, making, say, a flaw, maybe say along the lines of that there. So what I'm just going to put here to you is just quite simply, guys, if you don't mind me saying so, is take your time, read them all and choose. Now, when I say there to you, when I say to you that takes 10 minutes, and it could even take a bit more, but you have the luxury, you still have that time, okay? And then when you think you've read that, okay, then go tackle your five. You've got to do 5 questions altogether. You've 3 done already in, say, section A. You've got to do 5, okay? Now, if you allow for that 10 minutes, okay, and then 5 20s, okay, like that there. If you have, say, like the 10, and then you have here, should say the 5 times, maybe should say the 20, okay? That's bringing you to, in this case here, say 100, okay, and say 10 minutes. And that basically leaves you, should say, with 10 minutes left at the very end of the exam. Now, I'll get to that in a moment's time. But here's the thing. Because you've got a bit of flexibility, what if you're in the middle of a question and your 20 minutes is up and you're still not finished? That's okay. That's okay. You still have a bit of time to play with, okay? So you might get, once every now and then, you might get a question that's a bit longer than the others, and you might say, this one you might have to go on for another, say, 2 or 3 minutes, and that's not a problem. That's okay, because you see, this plan here that I suggest to you has a built-in flexibility, okay? Now, with it being the case, let's just say for argument's sake, okay, that you do have it all goes according to plan, and let's say you've got maybe say 10 minutes left. You're meant to finish at 12:30, 12:30. Let's say it's 12:20, and you have 10 minutes left. Now, a question people often say to me, Pat, if I have a few minutes left in the end of the exam, should I do an additional question? And I'm going to give you a very simple answer to that, a very clear and a very loud answer. No, absolutely no. Because I'll tell you why. In my experience, people who do extra questions are, in my opinion, are almost always wasting time. Allow me to explain very simply. Let's just show you a little very, very simple thing here, just for one little second, guys, and it's just this, okay? Just watch 1 second. Now, in section A, you basically have, okay, say the questions 1, 2, 3, 4, and 5. Now, leave them to one side, okay? And then you take, say, section B, and you've got a question 6, 7, 8, 9, there's 10, 11, 12, 13, and 14. Okay, there's your 9 questions. Okay, now just say for the sake of just make the calculation easy. What if, say, I do those 5 questions? Let's pretend they're the 5 I do. Now, remember, each question carries a grand total of 56 marks. Okay, just say it's a grand total of 56 marks. And what if, say, you literally ace question 6 and you get a full 56? Okay, so you scored a full 56 marks. 100%. I say, well done. Now, let's say question 7 you score, let's just say in this case here you score 51. Okay, let's say question 8 you hit maybe say 48. This guy here says a 46, and let's say question 10 is your worst question, okay, and you hit say 40. Let's just imagine they are the scores that you achieve, sorry, on the day. Now you have 10 minutes left, and you say, oh, I know what I'll do. I'll have a blast at this guy here. I'll have a go at him. And you absolutely get stuck into it and you're thrilled with yourself, okay? And you score 39 more marks, okay? Now you realize, don't you, you got nothing. You scored nothing. You see, you did get 39 marks, but the examiner looks at this and he sees 1, 2, 3, 4, 5, 6, 6 questions. He'll take your best 5. So by taking your best 5, he literally ignores that. That's gone. You see, guys, the whole thing is just this. If you do an extra question, okay, for the last 10 minutes or so, it'll only benefit you if you exceed what you've already got. Now, what if you do exceed? What if, say, you do question 14 and you score 41 marks? You don't get 41 marks, you get 1, because instead of giving you 40, he gives you 41. He goes for the 41 instead of the 40. So it took you 10 minutes to get 1 miserable mark. Wow, that wasn't a great return for money. Okay, that wasn't very, very good. So in other words, what I would actually argue to you is if I had 10 minutes left, what I'd be doing is I'd be reading over the 5 I've already done. I really would. And I'll tell you why. If you can even spot one mistake, if you could correct one mistake here, you could actually gain 3 marks. You see, to gain marks with an additional question, you have to exceed what you've already got, okay? And it's only the excess of what you, so in other words, if you get 41, as I said, you only get 1, you don't get the 41 because you already had the 40, okay? I will believe 10 minutes spent checking the 5 you've done, I think, would be far wiser thing. And that's why I say in the dying minutes, okay, what I would do is, and I simply stress this here, guys, is I would check basically the 5 I've already done. Now, the one exception to this rule is, and there's always one every year in the school that can do this, they are incredibly fast at writing. Like I've come across people and I don't know how the hell they can write so fast. And like, people have told me stories like Pat was finished with 40 minutes to spare and I checked everything. Now that's very rare you get this, okay? Now for a student like that, I'd say, okay, if you've everything done, you've got all your 5 questions done, you've checked everything, and you've still got maybe half an hour to spare or whatever, then I would go and do an extra question. Yes, absolutely. But guys, to be honest with you, those students are few and far between. To be honest with you, like, when I say you meet, you wouldn't even meet one a year, maybe one every second, every third year, something like that. Okay, and that's a problem that most people don't have. It's a lovely problem to have, by the way, but most people actually don't have that problem. So what I would say to you is, there will be your actual strategy. And the funny thing is, when I mentioned about 20 minutes for each question, the lovely thing about that is it's easy to follow. It's an easy rule. Like it's easy to time yourself for 20 minutes. Now, there was something I have to say, and it's just this here. I remember doing this with us in a class once, and I had a group of one student in particular was very, very serious. And when I mentioned about, say, the 20 minutes, spending the first hour during section A, he was very worried and he said, Pat, if I was finished after 50 minutes and I had 10 minutes to spare, do I have to wait for half 10 to move on, or do I take a 10-minute break? Well, I'll tell you one thing, lads, okay, how I actually controlled myself and didn't kind of let it roar them, I'll never know, okay? I won't even answer that, okay? Like, okay, you don't take a 10-minute break in the middle of the exam. The great thing about this plan is the flexibility of it, okay? If you don't mind me saying so. Now, can I just, as seeing as we're here, you know the way I told you you'd be picking 5 questions here. Could I just recommend 2 questions in particular I'd really stress you have a really, really good look at, okay? And I'll tell you what it is. I think question 6 is a superb question to do. Now, it's the set of short questions, okay? And the reason is that basically, guys, you're actually asked to answer 8 out of 12. Now, you know the deal here. You ignore that, you answer all 12, and they will correct all 12, and they'll give you credit for your best 8. Now, there's something you need to hear very clearly, and it's just this. Okay. Yeah, oh, by the way, I should have said in question 6, it's answer 8 out of 12. Now, before COVID, question 6 is we less questions was question 5. Okay. So once you go, say, 2020 and early years, it was question 5. And back then, we used to have to answer 8 out of 10. The choice wasn't as good. The choice is great now, 8 out of 12. Of course, what's the word I'm going to say here to you? Repetition. And that's what I'm trying to say to you is if ever you wanted to prepare, say, for question 6, what I would do is, okay, I might say maybe say, okay, I'll go back, maybe say I'll have a look at maybe say 2 years. I'll go to maybe 24, 23. I'll have a look at the short questions that he actually asked that year. And of course, have a look at the answers. The answers there, they're all available online, okay? And the fact of the matter, guys, is I'd have a look at the question, have a look at the actual answer. And what will surprise you is as you start to work your way back, okay, through the years, all of a sudden you're going to notice, oh, God, Pat, there's a lot of repetition. There's certain things that keep getting asked fairly often, okay? And you'd actually be kind of quite pleasantly surprised by that there, okay? And again, you see, if you think of it, guys, you've got to say the best part about maybe, so say, well, I mentioned earlier on about, say, between now, I think at the end of May is about 13 weeks. And if you say to yourself, you know what, I'll each week I'll try and find a time to do maybe say 2 question 6s. Now, once you go before 2020, it'll be question 5. You'll see it yourself. What'll really pleasantly surprise you is after you go back about 4 or 5 years, then you notice the repetition starting to kick in. And again, I'd be guided by that. You see, what I love about question 6 is if you have to get 8 parts right out of 12, imagine this, guys, you can get 4 parts out of 12. You can get a third of the question totally wrong and still score 100%. I don't know many exams that where that happens. Imagine get like a third of the question wrong and you still get 100% of the marks. So from a strategy point of view, okay, I think that's a great question to do. It won't come as a surprise when I tell you that well over 90% of the country do the question every year. It's the most popular question on the exam by far, okay? And then one small little matter, I'd also suggest it to you have a good old peep at question 14 as well. Question 14, if you don't mind saying so, is a kind of a great little question. And I'll tell you what I love about question 14. It comes in 4 parts, okay? A, B, say C, and D. And see, what you have to realize is they're like little half questions. Now, the deal here is you have to do 2 of those, okay? And if you get 2 of those done, then you basically have a full question. I often say that like that question has got 4 halves. I know it sounds a bit silly, but what I mean by that is each question is a half question. But here's what you must remember. Because they're separate topics, because they're half questions, he never gets time to get stuck into anything in great detail. What's the word I'm looking for? I find those questions are, can I use the word a little bit superficial? He basically kind of scratches the surface, never goes into any great detail. And I suppose really what I'm trying to say is they're kind of easier questions. And again, on the law of averages, of the 4 that's here, the chances are 2 of them will suit you. And I actually find, okay, of the questions on the exam, the most popular ones every year are 6 and 14. 6 and 14. And that's why, okay, I'd have a really good look at 6 and 14. I'd nearly go in with the plan, I'll do 6 and 14. Now, you might look at 14 and of the 4 parts, none of them might suit you. And that's the case. Okay, fair enough. That's not a big deal. You know, your plan didn't necessarily work out exactly as expected, but that's not a big problem. There'll be plenty to choose from. But what if you do, like most people do, 6 and 14? Do you know the reality then, guys, of the other 7 questions, you only have to answer 3. That's a good choice. That's good going. Okay. So I very much wanted just to mention that there to you. And then the one last thing I'll say about the exam before I do a little bit of physics with you as such, and it's basically just this. You know the way there is what I would call the comprehension question. Okay, just spell it out there for one small little second. Okay. Um, and the funny thing, guys, about the comprehension question, you know the one I mean, is where they write 2 or 3 paragraphs of English and then they ask you, say, a series of, say, short questions after that. Usually the comprehension is followed by what I would call, say, 8 short questions. Now, I'm always a tad concerned about this question perfectly. Now, I'm not saying to you don't, and I be true it. If it gives you a feeling 50-50 chance. I'd say about half of them over the last 23 leaving certs have been okay, and half of them have not been okay. I'm always just a tad concerned about this here. Now, what could happen is, what if say your favorite topic, just say your favorite topic was say X-rays, okay, and just say the comprehension question was all about X-rays, that could really suit you, okay, it might suit somebody else, okay. So while I'd say there to like don't ignore straight away, have a little read, but both of you read it and you're saying your gut reaction is no, this is not for me, drop it, let it go, ignore it, okay, because you have loads of choice, okay. So you'll be okay, so say with regards to that there. Now, that was just a kind of a few little lines I wanted to say there to you about what to do on the day of the exam. And again, if we just do a quick summary again, I was saying, but 20 minutes a question, okay, and I mean it for both A and B. Try and get section A out of the way, get stuck in there as much as you can. And they know what I like, by the way, about starting with section A. The questions are usually okay, and you get your mind thinking physics. You get your mind into the groove of physics, so to speak, okay. And then as you're writing, okay, your kind of brain is thinking physics. And that's why I think you'll find it easier to tackle section A. And do be careful with your choice of questions. Try and choose as wisely as you can, is what I'd be saying there to you, okay? Now, give me one little second, okay? I'm just going to check something here on the screen, okay? And just let's try and hear. Okay, so 1 second there, 1 second, okay? Now I'm just going to try and answer just two small little questions, okay? One was, oh, by the way, someone has here, sir. I love being called sir. Okay, I've just been knighted. Wahoo. Okay, like that there. Anyway, so all joking aside, I like that. Okay, nice little old-fashioned touch there. Will formula always work instead of definitions? Yes, absolutely yes. Can I come back there? When it comes to definitions, in actual fact, okay, if for example, okay, a formula has a choice between English and a definition, English or maths, I would always go for maths. So can I put a simple one there to you? Very simple. Okay. Well, what if say I'm in the actual leaving cert? Let's do a very easy one, and someone says to me, kind of define power. I'll simply go to my maths tables, I'll write down P, very simply is W, I say here, over T. I'll tell them P is power, W is work, T is time, and I collect full marks. So the answer to that question is yes. And then here, should we answer all parts in question 14? No. There's a very clear note to that, okay? Because with regards to 14, you see, the thing is just this: you're wasting time. And my point is the following: what I find happens to most people is when they look at 14, what happens usually is there's one part you don't like, there's kind of three you're okay with, okay? And then of the three, pick your better two. But do not just do two and then leave it, shall we say, at two. That's what I would actually say, okay? So leave it literally, guys, at two. That's what I would say. And very clear. I'm actually glad you asked me that, okay? And the answer then, shall we say, there is four. Is in this case here for four, do all parts? No, would be a very clear answer to that one there, okay? And you're very welcome there, guys, okay? Now, there are my so let me see. No. Okay, right. Okay, I'll hit two more questions here very quickly. Okay, if the question verb, okay, say was describe, are we still able to use maths or does it have to be English? Be careful there, you see, because okay, when they actually ask to describe something, okay, they're talking, to say, about English. Okay, now the thing is, describe usually refers to maybe say an experimental procedure, but just be careful one thing. I'll tell you where the maths would not work. If they ask you what is the meaning of. Just be careful with that. If the question says to you, okay, say, what is the meaning of? So if I said to you, what is the meaning of kinetic energy? You say, oh, that's energy you have when you're moving. That's kinetic energy to motion, okay? So what you really look out for there is the actual same meaning of. With definitions, usually they don't use the word describe, okay? It's usually definitions like what is or define, okay? But it asks for what is the meaning of English, okay? And then one thing there, how many formula derivations come up in the paper? Is it worth learning every single one? That's a really good point there. I think that is it Helen asked that question there. That's a really good question because here's the thing. As regards say derivations, now here's a bizarre thing. I'm going to say there's six, okay? There's six things you actually have to be able to derive, okay? And I'll tell you basically what they are just very quickly. There's first of all what are known as the three equations, okay? I'll say of motion, okay? You know the three equations of motion. Then you have to derive one from circular motion, the one that says V is equal to what's called O omega in circular motion. And then in the planets, you have to derive the fact that t squared is equal to, I'll write down 4 pi squared. I'm going to write down r cubed over capital G, capital M. They're the three for mechanics. Now, We then find in light, we have to derive the one that's for diffraction. N lambda is d. I'll throw in here, say, sine theta. In electromagnetism, the one that says F is equal to QVB, and then there's one little problem in electricity. You know one about resistors in series and a parallel. I know they're kind of like two separate derivations, but one of them says this. One says that say R is equal to R1 plus say R2, and the other one says 1 over R is equal to 1 over R1 plus 1 over R2. Now I tend to group those together, so I'd say 1, 2, 3, 4, 5, 6. Now, okay, someone said to me, Pat, that there's 3 there. Yeah, but I regard that as kind of one main derivation. Now, I'm not in the business of making prediction, but what I'm just going to say here to you is I would really give that guy particular attention. And the reason very simply is planets are, to put it very, very simply, long overdue. Okay, planets are long overdue. And we haven't had a decent question of the planets since 2020. And by the way, the 2020 exam was a COVID exam, which didn't really happen. So technically speaking, you could say it was really 2019. Okay. And it's just that we haven't seen that guy for quite a while. Okay. So I certainly would have a look at that. And then, as I always say, even if it doesn't come up, you'll have really enjoyed learning it anyway. It's such an exciting one. Okay. But I certainly would keep a very, very close watch on that derivation. But to answer your question, is it worth learning every single one? Do you know something? I know you might not want me to say this. I'm going to say yeah. And I'll tell you why I'll say that, okay, very simply, okay? It's because it's a lovely feeling in the exam when they ask for a derivation, it's worth 12, 15 marks, you know it, and you write it out, and you get a real, what I call feel good factor. I really, really think it is. Now, the only exception I'll make to that is, let's just say you said, I don't like electromagnetism. I'm going to leave out the topic. Well, then if you're leaving out the topic, you'll obviously be leaving out that corresponding derivation because, if you're not going to do the topic, then you're not going to do the derivation either. Okay, so that'll be fair enough. Okay, so you'd aim to try and do as many of them as you possibly can, and that's the list of your derivations. Now, do you know what I was going to do here just for one small little minute, guys? Okay, and it was just this here. Just give me one small little second. Okay, what I'm just going to do here very simply, and it's the following. Okay, um, I'm just going to show you something, okay, of how, say, I might teach myself, okay? And I'm just here just for a particular reason, okay? And I'm going to pick a nice little topic here, just for one small little minute. And the topic I just wanted to pick here, ever so briefly, was the business, say, of the Doppler effect. Now, let me just write this down here for one small little minute, okay? Say like so. And I'll just explain to you just a couple of things, and then there's a couple of things I want to show you, particularly from the past papers, okay? Now, one small little issue is just this. The Institute of Education, we're based on Leeson Street. Now, I don't know if you're familiar with that part of Dublin, but if you walk down the road, you end up in Stephen's Green, a lovely park there in the city centre. And if you go to Stephen's Green, there's a gorgeous duck pond, okay, as I call it. And imagine, say, a really calm day where the water in the pond is very still. And you have a little coin, whatever, and you throw it into the water like this here, you make a bit of a splash, and you set up a kind of a pattern, say, like this here on the surface, say, of the actual water. Now, very, very simply put, guys, okay, these are circular patterns, okay? And the gas thing is that splash there is the center of them all. So they have a big fancy name for these. All the circles have that as they have the same center. They're called concentric, okay? But the gas thing is those circles, they're not called waves, they're not called ripples. Those circles are officially in physics known as a wave front. That's what they're actually known as. And if I was to do a good job, I find it very hard to draw this myself, but if I did a good job, that distance there and that distance there, they'd all be the same, and those distances are known as wavelengths. But here's the gas thing, and it's just this. Where I made the splash, okay, that's called the source of the wave, okay? And of course, you see the wavefronts forming like this. But what if that was, so say me talking? Wavefronts of sound would come out of me as well. Now, the only thing is, because we live in a three-dimensional world, there wouldn't be so much a circle, there'd be more like spheres of kind of, say, sound wavefronts, okay, is what you would actually get. So the funny thing is that would actually happen, okay? So let's just say, for example, okay, let's just say I came along here, okay? I'll just kind of put to say, okay, let me put out my, that's my highlighter, or something, what the hell it was called, okay? And there's my pencil pair, okay? And what I'm going to put there to you is, what if, shall we say, that was a person, okay? And that there was maybe, say, somebody with a music system, a speaker for music. And let's just say it's giving out sound. The sound from the speaker would go over to the person in a series of what I call wavefronts, and it basically all come out like that. But Doppler wants to ask one simple question. That's the person, and that's the actual speaker. What happens if that moves towards him, or moves away from him, while it's giving out the sound? So what happens if the source moves as the waves are coming out? Now, the answer very simply is you get a distorted pattern. And you do get circles. Oh God, yes, you do. Okay, but here's what basically happens, guys. Okay, your circular wavefronts are like this here. They're still circular, okay, but they're not concentric. Okay, now can I explain what I mean by that? Okay, they're still circular. The guy's moving over here, say to the right, but they're a little bit squashed. You see, that dot is not the center of all the circles anymore. You get a distortion. And let's just say this was the observer. Okay, well, by the way, you might notice I'm not very good at drawing. I draw stick men. Okay, I think I never progressed beyond junior infants in terms of drawing. Okay, I must have had a very bad childhood. Anyway, the point is just this. This thing here, guys, okay, this distance here would be the wavelength again, but you can't help but notice, gosh, compared to up there, it looks like the wavelength is actually getting smaller, and it actually is indeed. So this poor unfortunate guy, if this is the person and if the speaker is moving towards him, this guy will hear smaller wavelengths than what he should do, okay? And then the gas thing then is if the source passes him by, you're still going to get your lovely circles like this here, but they won't have the same center. They will not be concentric, okay? They'll be a bit squashed over here on one side, okay, as we can see here again. But the difference is, as it goes away, look at that space there, guys. That's a lot bigger, I should say, than what it was up here. And therefore, you'll actually experience what we will call a larger wavelet, like so. So if they ever ask you to explain Doppler, all you have to say is if a source moves to somebody, that person will witness smaller wavelengths. And if it moves away, they'll witness bigger wavelengths. Give them that diagram. Now, I can't draw, but damn it, guys, even I can draw that, okay? And and by the way, actually I mean draw the stick man as well, okay? Like that there. It's not an art exam, okay? And really, what you're trying to say is this is what's happening. But then there's a very clever little piece of maths here, and what's that? If I come over here for 1 second to remind you, you know the way speed is frequency times wavelength. Now you know that, okay? Now one small little issue, and it's just this. That means therefore speed divided by wavelength is actually equal to frequency. But here's a gas thing, guys. When you have an equation, something left, something right. Frequency is on the right, wavelength on the left. He's above the line, he's below the line. When one is above, one is below. They're called inversely proportional. And what that basically means, very simply, is okay, that if the wavelength goes down, the frequency goes up. So you see, the frequency, by the way, goes up if the source comes towards you. And then the flip side of that is when it goes away, if the wavelength goes up, then the frequency here goes down. Now, people have said to me, Pat, if I'm explaining Doppler, should I talk about wavelength or talk about frequency? And I get full marks and leaves hurt. The answer is both. Okay, you talk about both items. Okay, that's basically what you do. So the gas thing, if you don't mind me saying so, guys, is okay, in a case like this, source moving to a person, you talk about a smaller wavelength with a higher frequency, of course, moving away, greater wavelength, corresponding with a lower frequency. Now, if you can draw that little silly little diagrams, little stick man, and put a bit of words to it, okay, absolutely spot on. Okay, and incidentally, this approach I'm taking, I didn't come up with this myself. This is not the Pat Doyle discovered approach. This is the approach that the department wants you to do in order to get your, say, your full marks. Now, there's one small little caveat here, and it's just this: maths. Okay, now here's the catch. The mathematical formula says frequency is equal to frequency by the speed of the wave over speed of the wave, I'll say plus and minus the speed of the source. Now, hold on. What I just said there doesn't make a lot of sense, but just relax for 1 second, because why? That mathematical formula very, very nicely is in the actual maths tables, okay? Happy days, okay? But here's the thing. There's two frequencies, one to the left, one to the right. And then we have to distinguish, one of those is the correct true frequency coming from the source, and one is a false one that the guide person hears. The false one is called F dash in the maths tables. So the F dash is what the guy hears, okay? And then the F is the actual frequency. Can you give an example? Let's say there was a person, and let's say there was a speaker, and let's say you listen to a piano recital, and someone plays the note middle C. Now, middle C, if in physics, will have a frequency of 256. So the speaker is stopped, and if he plays middle C, this person here will hear middle C. But if the speaker starts to move towards him as it gives out middle C, he'll hear a different musical note. It's bizarre. So if ever you listen to sound, as the thing making the sound is moving, what you hear is not the true sound. You're being fooled. It's a bit of a con job, okay? You're being tricked. And that's what Doppler is basically telling us. Now, so F is the frequency, shall we say, of the actual source. F dash is what the guy hears. Now, C is the speed of what's called the wave, and use the speed of the source. So for example, okay, if there's my actual speaker, C is the speed of the sound wave, okay, and they'll always give you that in the exam. And then U is how fast the source is moving. So let's say this is me and I was running towards somebody like that there. It's how fast I'm running. That's what the U refers to. Now, a lot of people don't like that. A lot of people think that formula is a bit tricky, and a lot of people do this. They write down instead, they write down FO is equal to, they go F with a small s, they've got a C, and below the line, the C, and the plus and the minus u. And the reason for the small s is that's called the source frequency, and that's called the observer. And I often ask students, I've been doing this for years and years and years, which formula would you prefer me to use? And I find the majority of students say, Pat, I prefer when you go with FO and FS. We find it easier to follow. We find it less confusing. And again, look, at another personal choice. If you're used to that and you're happy with that, stay with that. If this works better for you, then work with that there. And the only annoying thing about the plus and the minus is you got to remember this. Use the plus when the source is going away from you. Okay, that's the problem there, guys, when it's actually going away. And then use the minus, okay, when the source is actually going. I'll write down here, say, towards you. Now, what's really annoying about what I just did there, if you don't mind me saying so, is unfortunately the bit about the plus and the minus, they don't tell you in the exam. They do not tell you that in the maths tables. Unfortunately, that has to be remembered. Okay, every now and then there's just no escaping it. There's a tiny bit of what I call memory work that we just have no choice. We just simply have to get our head around. Okay, and there's nothing we can actually do about say stuff like that. Now I'm just going to do two things here very, very quickly, and it's just this. I'm going to get this guy here for one little second, just going to pop him over here like so, and I'll tell you what I actually have here. I'm just leaning over here myself because I actually happen to have all my questions here on sound, okay? I haven't kind of say laid out here, but I'm going to pick two questions. I'm picking these here for a reason, and the reason I'm picking this is because you can actually get these questions handy enough. I'm going to tell you where the first one is, okay? Tell you basically what it was. It was way back in the year 2014. So I'm going back 11 years ago. Now, there's one reason why I picked this, okay? And he said this here. He said in this question, okay? Sorry, I do beg your pardon. It was question 10. It was question 10 in 2014, okay? Now, you can find it yourself. Just give it a little reference, okay? But here's what the guy said. The question reads like this. An ambulance siren emits a sound of frequency 750 hertz. So he's after giving you the frequency, okay, coming from the siren, and that was 700 right down and 50 hertz, okay? That was the frequency of the sound from the siren on an ambulance. Now, when the ambulance is traveling towards an observer, the guy used the word towards, okay? So basically, okay, I know what that means. I'm going to be using the minus sign. He said the frequency detected by the observer is 820 hertz, okay? So basically, he said that when it's going towards the frequency is going to be 820 hertz. Now he clearly said, I'll say it again in English, the frequency detected by the observer. So that's clearly the observer frequency, FO. So this must be the FS. So he basically gave me FS, FO, and he gave me the word towards. Okay. Now, the question I was actually asked is, what's the speed of the ambulance? Okay. How fast is the ambulance going? But he told me, guys, at the end of the question, the value for the speed of sound and air was 340. Now, do me a little favor. You have the two F's, you have the C. Look at the maths. You know the value for C, you know the value for the two F's, go find the value for U. That was the question. Now, if you do me one small little favor, I'm going to write down the following. I'm going to write down FO is equal to, say, FS. I'm going to have a C. I'm going to have a C here minus a U. And you know the reason for the minus? Because he said towards in the question. Now, what I'm going to do is for the FO, I'm going to write in the 820. For the FS, okay, I'm going to put in the 750. The C value was the 340, and below the line is the 340 minus U. U is the guy I don't know. I just cross multiply here. I basically get to say my 340 minus U is equal to, now I have my 750 by my 340 over my 820. If you do me a tiny favor, I'll get something say like 340 minus U is equal to, and I got the number there to be, roughly speaking, okay, about say 310.98. So when the U went to the right and the 310.98 came to the left, to a good approximation, guys, I got 29.02. And I'm going to write in meters per second. Now, one quick question. Why did I pick 2014? Because, guys, 2014 is 11 years ago, and the examiner likes to repeat questions. There's a classic question, okay? And here's the thing, I was actually able to measure the speed that an ambulance was traveling at, which basically means I can measure the speed of a moving vehicle. And that's a technique used by police forces all around the world. Speed cameras use the Doppler effect to measure the speed of a car. And there's a lovely little maths question. Now, it would be a shame if I don't show you my next question. You're really going to like this one, okay? And I'm going to tell you very, very simply why, okay? Now, I'm going to just say for a second, that was just 2014, okay? Now, I'm going to leave Doppler sitting there like that for the moment, okay? And I'm going to tell you very simply why. You see, I'm going to go to the year 2017, okay? let's give me one small little second, okay? There was a question 7 that year, and I'm just going to have to find this question so I can actually just clarify this here for you. But something happened in this question that I need to be aware of, okay? Like, give me one little second, okay? And it was just this. Could I read the question again? Now, in this question, the C value was given as 340, as always, the speed of sound. But he said here, a source is emitting a sound wave of a certain frequency is approaching an observer. He uses the word approach. Okay, say like that there. So it's going towards. So I know I'm going to use the minus sign and it's giving me the value for C. But here's what the bit I want you to hear. The frequency observed is 15% more than the frequency of the sound. So basically, guys, he's saying FO is, and he has here 15% more, okay, than he said here FS. Now, how do you use that? And the answer is, see this mathematical formula? Can I write it down? Can I write down FO is equal to, can I write down FSC over C minus U? And you know the reason for the minus, because he said approach. Now, FO, if it's 15% more, Pat Doyle says 1.15 FS. If you're 50% more, you're 1.15, and that's equal to, I'll say FS. The C is 340 over, and here is 340 minus U. Now, do me a little favor, the FS's cancel. But I need to ask you a question. When it was 15% more, I said 1.15. What would I have said if it was 25% more? It would have been 1.25. 10% more, 1.1. Now, give me one little favor, because there's a reason why I simply have to show you this, okay? Give me 1 second. Can I cross multiply? I get 340 minus U is equal to, and I'm left here with 340 over the 1.15. Now, hold on. That gave me, say, 340 minus U is equal to, and what I got then here was 295.7. And when the U went to the right and the 295.7 went to the actual left, okay, what I got here very simply was 44.3, and I'll simply scribble in here meters per second. Now, hold on. That was a very clever question, about the 15% more. But the reason I picked 2017 was 3 years later was 2020. Okay, now in 2020, okay, there was a question 12C. And I've only given the actual reference here. Give me 1 little second. You're going to like this, okay, because I'm going to write down here, say 2020, okay, it was a question 12 part C. And give me 1 little favor. He was talking this time, okay, about a car. Okay, now, car is approaching an observer. And again, he uses the word approach. Okay, so I know what that means. Okay, it means it's going to be going towards. Then he said here, the source appears of a frequency 20% greater than its frequency at rest. So this time, guys, he has FO, okay, is, he said here, 20%, I'll say more than, okay, I'm going to say FS. Now, before I waste any more of my lovely ink, how will I handle 20%? 1.2. Same question, just 1.15 became 1.2. Now, hold on, don't go away. That was 2020. Then you go to 2023, and it was this question 14B that year. Now, you know what's coming. I bet you're way ahead of me in this one, okay? But I have to say something here to you for 1 little second, okay? When I go to say the 2020 question 14B, now I'm going to wonder, would you like to make a guess at this? He started at 15%, then he went to 20%. So do you think next time around, did he continue with the increase? What did he go to? You're having a guess. What percentage do you think he went for? Okay. Did he go up? Did he go down? Okay. And I am not joking, you guys. In 2023, question 14, FO is, he said, 20% more. Okay, I'll say here than FS. And you're saying, Pat, that was the same. Yeah, not only was it the same trick, it was exact same numbers. He didn't even change the numbers for us. So don't let anyone out there ever tell you he doesn't repeat tricks. I mean, come on, that was 2017, that was 2020, and then the same trick again in 2023. What flabbergasts me is, how could anyone who sat the Leaving Cert in 2023 not get that right? I mean, come on, they have to have seen it if you're looking at the past papers. And that's why you see, that's the great thing to say about the past papers, okay? Now, you're probably sitting there thinking, Pat, 17, 2023 ain't going to happen till 26. We don't know that. Yeah, okay, it may not be in the category of highly likely, okay, but it certainly could be. There could be a bit of, it could be a possibility there, if you don't mind me saying so. Absolutely, yes, okay. It's not beyond the bounds, say, of possibility, okay, that the guy could come along and do that there. And I know I actually I've just given you a reference. You can see the questions yourselves, and if you want to go online, you'll be able to kind of get your market schemes, get your answers there as well, if you don't mind me saying so. But I very much want to just to show you stuff like that. And see, if I was to lift up that page again, okay, what's lovely about this is, if you don't mind me saying so, is you have here, I should say, your little explanation of the Doppler effect. There's your little pieces of maths, and then the questions become terribly repetitive. But it goes back to, I think one of the big things that I'm kind of saying here to you today is working with those past papers. Now, my classes that I do here, just to show you an example of what I do is I give out kind of say past paper solutions. Like for example, I've got a little booklet here, say like this here, okay, and that covers the entire section. Say like I do a little question, give the fully worded answer, and so on, okay, and that's what I do in my various courses, okay. Just if you're interested in something like that. But even if you hadn't access to that, there you can still actually just go onto what I call the department's website. Now give me one little second. I'm going to hit the little chat function again, okay, and let me see what the lights people have actually thrown at me there, okay. Give me one little second. Okay, yeah, here we go. Okay. What should you do if you are in a situation where you answer all questions quickly? Should you try slow down, and if you decide to do an extra question, how many should you do? Okay. If you're somebody who can write really fast, I would slow down. Yeah, I would. I don't know about you, I am notorious for making mistakes. Like, I mean, I make mistakes like everyone does, for God's sake. Okay, like if you don't say 2 + 2 is 7 type of thing. Okay, but the thing is, if I make a mistake and my teacher, one of my students spots it, we correct it, we get on with the job. If you make a mistake, you lose marks. So first of all, I would say, yeah, I'd slow down. Okay, that's what I would do. And my goal would be to do no extra questions, but I put it this way, like I would say try and just do the actual eight. That's what I would actually say there to you. That's what I'd be inclined to do. Okay. Now, now there's a nice one. Okay, I love that question. Uh, and one to sir again, okay, as you can see there, okay. If it was 15% less, would it be 0.85? Yeah, absolutely bang on, okay. Yeah, absolutely. Oh, and then, sorry, one person asked me there, what does the 20% change to? Sorry, the 20% would go to, say, like this here, it'd be, say, 1.2 FS, okay, would be equal to, and then over here, you'd actually have the FS, should say, by the 340 over, it'd be, say, the 340 minus the U. Can I just box that there for one little second, okay, like so. So if it was 20%, it would be 1.2, and then the FSs would cancel like that. And then someone asked me there if it was 15% less. And by the way, just as a matter of interest, um, if you had a situation, if he said to you, say like go back here, it was 15% less, it wouldn't be approaching, it'd be going away. Okay, and then not only would that be the case, you are dead right. I'll just draw a line here. Okay, if someone said something like 15%, say less, okay, like that, then what you'd actually have is when you write down FO is equal to the FSC over, it'd be C plus U, because you see what would happen is this time you'd be going away rather than towards, and then this here would become, say, 0.85, and then you'd have here, say, FS would be equal to, it'd be the FS, the C would be given as usual 340 over, you'd have here, say, the 340, I'll say here, say, plus the U, and the FS's would obligingly cancel. Yeah, okay. Actually, that thing of 50% less, okay, I think you should get the job right in the actual questions, okay. Yeah, that would be absolutely it. And in fact, you know what, when you said it to me, I say well done for that question, because that would be slightly original, if you want to call it that, okay? And of course, if you said 20% less, it'd be 0.8. So it's just a nice little kind of a question, okay? And as I always say, always, should I say, always trying to be guided by past papers because of the fact of the high level here of repetition. Now, is there any other variations of the formula they could actually ask? Now, one small little matter, and it's just this. Can I just take this up? I'm going to show you one that they do actually like to ask you. Tell you very quickly what it actually is. It's not a bad little one, and I'll tell you what it is. And one more thing on Doppler, they do actually like to quiz you on. I'll tell you what it basically is, lads, okay? And it's basically just this here. What if, say, you had something, say, going in a circle, say, like this here? Imagine if a piece of string, okay, like this here, there's a piece of string, same piece of string here. And what if I had a whistle or a buzzer, and the buzzer was there as well? And what if, for say, this here was my observer over here? Now, if the buzzer's going around in the circle, when he's here, he's traveling like so, curves up and then goes away like this. So what basically happens is if you're going in a circle, you're going towards then you're going away, you're going towards, and then you're going away. So you'd have the away and the towards to be two answers you'd have to do, okay? And coincidentally, okay, if you don't mind me saying so, he has actually asked that one, and that was back in the year 2016, in 2016, and it was this question, let me get it right here for you, question 12, part C, okay? By the way, if you're sitting at home there thinking, Pat, do you have all this stuff memorized in your head? Uh, it's kind of sad to say, but I kind of sort of have, yeah, yeah. And I know it's kind of sad, like I can't remember the name of my children, okay, like that there, like okay. But the thing is, I've got important things learned off like that there. In fact, sometimes I forget my own name, like okay. But the thing is just this: what I'm going to put there to you guys is, yeah, this would be a great little question. And what will actually happen is it'd be a lovely, easy question, okay. What happened is when you be going in a circle, you see, they'd actually ask you what are the highest and lowest frequencies, and the highest frequency would be going towards, and the lowest frequency would be going away. And what it basically means is I'd have to do both Doppler twice, one with the plus and one with the minus. And again, if you want to check out a sample question, say like that there, the one from 2016 will be to one to absolutely have a look at there. Yes, definitely. Okay. Now, just pause there for one little second. Did anybody want to lash another question at me there? Okay. We have a couple of minutes still left to go there. So if anybody wanted to raise a couple of questions, now would be a very good time to do so. Okay. Um, has okay, sorry. Thank you for your earlier answer to my question. Has the emphasis on questions changed over time, such as more modern physics? No, no. The funny thing is, your syllabus has been on the go since the year 2002, and do you know what? While there have been, slight little changes, not really worth talking about because there was never any kind of an update to the syllabus. There's never, anything like that there at all. So really and truly, the questions more or less for the last 23 years have been the same. What I would, however, do is it's not going to be possible to do all the past papers. So I'd start with 2023 and I'd work, sorry, 2024, beg your pardon, and I'd work my way back rather than going the other way. I'd work back. And like, if you could manage to go back 10 or 15 years, wow, that'd be brilliant. That'd be a great achievement. Okay. Now, you have here many physicians do we need to know. Um, I think you mean how many physicists, okay, but that's okay. Spelling doesn't really matter, okay? Now, that's a good question, okay, again, about what physicists do you need to know? But here's the gas thing. Every now and then you get a tiny little history question, but have you noticed, okay, I'll just write the word here, history, for one little second. Have you noticed that when they ask about, say, the lives of different scientists, they take the questions from two areas, okay? They quiz you on what we would call, say, the people you meet in modern physics, okay? Or the guys you'll actually meet, say here, say, in particle physics, okay? So it's the last two topics that seem to kind of say pick from the modern physics and the particle physics, okay? And there's any hint of an Irish connection at all, okay? Any hint of an Irish connection, watch out for him. I think the golden boy of physics, okay, has to be a chap called Walton, Walton, okay? Good old Professor Walton, lovely man, okay? He was Professor of Physics in Trinity for many years. Actually, his initials are E.T.S. Walton, okay? And he actually, the reason, well, he's famous for two main reasons. He's Irish, okay? But as well as that there, he is a Nobel Prize winner in physics. In fact, he's the only Irish person to win a Nobel Prize in physics. As I always say, yet, pretend cough there, okay? I dream on that I might win one myself. I never will, of course. Okay, but the thing is, Walton is a man, a great guy. I actually met him, to say, on a few occasions. Absolutely third gentleman, wonderful individual. Okay, passed away there about over 20 odd years ago. But just I always keep a little eye on him there. But to answer the question, basically focus on the guys in modern physics and particle physics. Now, what were you doing to change the percentage from more to less? Oh, okay, but basically, okay, but when I'll go back to that thing there again. Give me one little second there. I had it there a minute ago. Okay, basically, what I'm doing is when they say 15% more, that would explain just. See, it's the same. 50% more means it's Fs plus another 0.15, so 1.15. And when it was, say, like this here, say when it was, say, 20% more, it's the Fs plus another. See, 20% is zero point 0.2, so 1.2. If it was 25%, okay, it'd be 1.25. And then when it was the less bit, okay, like that there, okay, when I was actually going to say less, if someone says something like this here to you, just say they said, I'll just draw a little line here, okay. If someone said, say, 15%, but I beg your pardon, 50% less, what that would be, it's a 1 minus the 0.15, and that's where I get the 0, say here, say 0.85 from. That's what I would get, say, in that there, okay? And then, oh, question there, would I be able to leave electricity out? Now, I'm going to put a very simple question here, question back to you, okay? Should you leave out electricity? What I would say here to you very, very simply is, what grade are you looking for? Now, if you said to me, Pat, I'd be delighted with H3, the answer to the question is yes. If you said to me H2, I'd say maybe leave some of the stuff out, okay? Maybe leave some of it out. Or what you could do is concentrate on your experiments in electricity and then leave the rest of the stuff out, okay? If you're chasing H1, I'd say, gosh, that could be a dangerous move. I really, really mean that, okay? So if you're H1, don't leave out electricity. If you're looking for H2, maybe focus on the electricity experiments, okay, and leave out the rest of it. And if you're looking for H3 or H4, then yes, the answer is yes, you could afford to do that. Absolutely, yes, you could. Okay, so that was just that there. Okay, now, now let me see here. One little question there. Would you need to learn methods for Section A experiments? No, no, no. They never, if you look at the past papers, they never quiz you on the method. What you need to do, as I said there, I think I have it here. I'll go back a little bit here. So one little second, okay? I have it here somewhere. I think, at least I think I have, okay? Sorry, it might have been before this. Like this here. I'm just going to say here to you, yeah, what you would do is, okay, there was my list. I said, be able to draw a diagram, just be able to comment on what data you measured, not the just what measurements you make in the experiment. And make sure you know the maths question. If there's a graph, know how to draw the graph, and then always have one or two ways of improving the accuracy. Okay, so I say data rather than method. See, the fun thing is, guys, okay, that in most textbooks the method takes up nearly 10 lines, like, you know, far too much to learn. Okay, and you would not need to do all that there. Okay. Now, is circular motion commonly asked? Simply answer that question, by the way. Sorry, give me a second. uh, okay, I love the way this question was phrased here. Okay, if the examiner becomes a lunatic and asks us the method, okay, what about that? Nah, that's not happening. Okay, actually, he's a very smart guy, very smart man. Okay, chances of that happening, nah, ain't gonna happen, guys. Okay, I wouldn't be too worried about that. Okay. There's enough lunatics in the world, but examiner is definitely not one. No, right guy, right guy. Okay. Is circular motion commonly asked? Simple answer to that question is no. But the reason circular motion concerns me slightly this year is I think the planets could be looking good, and the planets and the circular motion are kind of interlinked. Okay. So, and by the way, that's the only reason why I'd be a tad concerned about the circular motion. What would be the most important? What would be the most important topics to learn? Oh, that's one. My God, that's a tricky one because that's one I can't actually answer, to be honest with you. I'm not trying to not answer your question, and I don't mean to be in any way rude, but you see, like really and truly, if I had the answer to that there, my God, I could make a fortune. I could selling my answers. Unfortunately, it's a hard one to pin down. Now, for question 5, would you answer all 12? Oh yes. But by the way, when you say would you answer all 12 questions, or just say to them, answer all 12. And by the way, what you're saying, question 5 is actually going to be question 6 because of an extra question in section A. But that's okay. That's okay. Would you believe it? I still myself call them the question 5s, even though it's nowadays called question 6. Since COVID, they've called it question 6, and the answer definitely yes. Answer all 12, and then correct all 12, and they give you your best 8. Okay, absolutely yes. Okay, that's a no doubt about that there. Okay, um, is there any occasions when defining the definition has to be a worded answer, not an equation? The only thing there would be there are a couple of scenarios, for example, say where there is no equation. For example, say if someone said to you what is meant by radioactivity, okay, there's no like the definition of radioactivity, there's no actual formula for that. So obviously you have to give the words. If I throw another one at you, what is meant by an X-ray? Okay. Um, and what the answer to what is an X-ray is, the answer you give there is it is a photon, okay, of, should say, what we call, say, a photon of electromagnetic radiation of very high frequency. So like there's no maths question, there's no maths formula can define, say, what an X-ray is. So something like that there. So the answer is yeah, there would be occasions, okay, things like say, the one that comes to my mind is, say, define radioactivity, because there's no actual formula that can do that for you. What is an X-ray? Okay, like if I ask you again, what is the photoelectric effect? Okay, well, there's a photoelectric effect equation. That's not the definition. So there would be there. And again, you see, if you go back over the past papers and if you look up, say, the question and then go and look up the corresponding answer, that's how you'll be absolutely crystal clear, should say, about that there. Now, what would you need? Sorry. What would you need for, I'll go back there, let's get to that side. What do you need for demonstration experiments, or just go through the ones in the past? Yeah, literally the ones in the past paper questions, not the textbook past paper questions, okay? Like that there. Um, the other one there is, apart from circular motion and the planets, what do you think are the specific topics? Possible, by the way, to pin that one down. And I'm not trying I don't think, I hope you don't think I'm trying to avoid your question. I'm not. Very, very hard to answer that one right there. One last one there. What are the frequency and wavelength ranges for each kind of light? Okay. Textbook mark schemes seem to give different. Oh, the frequency and wavelength. Oh, I see what you mean. I know what you mean by that there. And the thing about that is you don't have to get those bang on. Like for example, okay, if you take say red, orange, yellow, green, blue, indigo, violet, you don't have to have the exact values of frequency and wavelength. Absolutely not. Once they're there, they would be what's called approximate values. Okay. To give you an example, so say, like say, if you take maybe say something, say maybe I'm going to say like red light. Red light is usually somewhere between the 600 to 700 nanometers. So like you don't need exact figures for that there. Now, how many non-mandatory experiments are there? Ah, that there, okay. Off the top of my head, I think we were just about to say 25 of them altogether. But again, the best way to figure that out is, say you're revising sound, look up what demonstration experiments they're asking in sound. And I keep going back to one thing: be guided by the past papers. Now, guys, I have technically ran out of time. Okay, I think I'm going to go. We don't actually have a bell, so I'll go bong myself. So before we go any further, I'll just say a couple of quick things. Thank you very much for listening to me here for Saturday afternoon. Not easy to do so. I sincerely hope you gained something from the sessions here today. Could I wish you all the very best of luck with your studies between now and June? And more importantly, could I wish you all the very, very best of luck in the exam in June? Okay. So thanks, guys, for your attention. Best of luck. And you know what? Maybe we'll cross paths. Okay. Shall say, like, not in one of our courses. Okay. Great if you actually did. Okay. Thanks a million. Okay. Bye. Oh, thank you for all those thank yous. Very much appreciated. Okay. Thanks a million.